Hello all, in this lecture we will discuss the number of trailing zeros in n factorial, okay, by the fundamental theorem of arithmetic. Okay, so our topic is number of trailing zeros. Okay, we know that the number positive number 5 factorial. 5 factorial we know 1 into 2 into 3 into 4 into 5, that is it is 120. So the number of trailing zeros is um, number of trailing zeros is equal to 1. Okay. Similarly, when we consider 9 factorial, it is we know 1 into 2 into 3 into 4 into 5 into 6 into 7 into 8 into 9. There is again this 10. When we look at this 5 factorial, we know that this 10 is obtained by the product of 2 into 5. Okay, when we consider 9 factorial, there is only one product 2 into 5. That is the factor of 2 and 5. That means the power of 2 and 5 are only one times, comes only one times. So we can rewrite this as 1 into 3 into uh, 4 into 6 into 7 into 8 into 9, and let it be 2 into 5, that is 10 into 1 4 is there. From that 4 we can write 2, 2 only, 2 square, but there is no 5 again coming, so there is only one factor of 10, isn't it? One power of 10, that means the power, highest power of 10 in this 9 factorial is also 1. So therefore, without calculating 9 factorial, we can say that the number of trailing zeros in 9 factorial is equal to what? Is again equal to 1. So when the number becomes larger and larger, so it is not possible to write all the, suppose when we consider the numbers like 720 factorial or something larger numbers. So in that case, with listing all the factors, all the numbers from 1 to that fixed number is not possible, not very easy. So there is one method for finding this number of trailing zeros in n factorial. Actually, we know from this two examples, we have some hint that the highest power of k, the highest power, that means 10 raised to highest power of 10 will be, how many times 10 repeats will be the maximum number of zeros, number of trailing zeros in that n factorial, isn't it? So using the fundamental theorem of arithmetic and using the floor function, we can find a method or an algorithm for finding the number of trailing zeros. So in this lecture, we are discussing that one. Okay. Hence, each trailing zero corresponds to a factorization by 10. So the number of trailing zeros is k if and only if k is the largest positive integer such that 10 raised to k is factorization by 10. So the maximum power of 10 coming in the highest power of 10 coming in the factorization of that number is the number of trailing zeros. Okay. So let's look at some example. First one, find the number of trailing zeros in 112 factorial. We know by fundamental theorem of arithmetic, we can factorize 112 factorial by the prime numbers, and we write 112 factorial as in our required form, that is 2 raised to a, 5 raised to b, 2 raised to a, 5 raised to b into c. What is c here? We write in this form because we need the maximum power of 10. coming in this factorization. So we write all other factors, prime factors, the product of prime factors as C itself. We call it as C. So A and B are both the positive integers which are the powers of 2 and 5 respectively, and C is the product of the primes that are remaining in this factorization. So note that C is not a prime number, but it is a product of the prime numbers other than 2 and 5 coming in this prime factorization of 112 factorial. Okay, so the number of trailing zeros in 112 factorial is equal to number of the products of the form 2 into 5 in 2 into 5 in a prime factorization of 112 factorial. Okay, so this is equal to and we know one more thing is that in 112 factorial the number of that means 112 factorial. A 112 factorial contains all the product of the integers from 1 to 112. So in 112 factorial, it contains among multiples of 2 up to 112, and a 1 or 112 factorial contains, we can write in this way, that is 112 factorial contains all the multiples of 2, up to 112, and multiples of 5 up to 112, isn't it? Up to 112, since 112, since what is the reason? Since 112 factorial is equal to, is the product of the first 112 integers up to 112. Okay, so it must contain all the factors of 2 up to, all the multiples of 2 up to 112, and all the multiples of 5 up to 112. Okay, and one more thing we can notice here in this is that number of or it is easy to see in that number of multiples of 5, number of multiples of 2 are greater than number of multiples of, greater than the number of multiples of 5. It is clear, multiples of 5. Hence we can say that the factor A, the power A is greater than B. Okay, so the number of trailing zeros. So in order to find the number of trailing zeros, in 112 factorial is same as the number of number of what? A number of highest power of B. That is, this is equal to B. That means the number of powers, highest powers of B in the number of highest power of 5 in what? Number of highest powers of 5 in 112 factorial. Okay, that is, this is equal to B. Now we obtain. Now we have to calculate the B. So to find B, first we find number of positive divisors, number of positive integers less than or equal to 1112, less than or equal to 1112, and divisible by 5. Divisible by 5 is equal to greatest integer 1112 by 5. This we have already discussed. So this is equal to 1112 by 5. It is equal to 22. Okay, 110 is possible. Now each of them contribute a 5 to the prime factorization. So each of them contribute a 5 to what? The prime factorization of 112 factorial. Now a number of positive integers less than or equal to 112 and divisible by 25 we have to look. Now the number of positive integers less than or equal to 112 and divisible by 25 is equal to greatest integer function 112 by 25, and this is actually equal to 4. Now, why we calculate this is because 112 factorial contains 1 into 2 into 3 into 4 into etc. into 25 into 26 into etc. Up to 100 into etc. into like that up to which number? Up to 112. So each of these numbers, each of these 25 and its products like that 25 also and 5 product, all these numbers will contribute a 5 to this factorization. So this is equal to 4. Now each of them contribute and each of these numbers also contribute, each of them contribute an additional 5 other than that obtained by divisible by 5 numbers. Each of them contribute an additional 5 to the prime factorization of 112 factorial. അപ്പോൾ ഇതിൽ നിന്ന് ഓരോന്നിൽ നിന്നും നമുക്ക് വീണ്ടും ഓരോ 5 വീതം വരും. So the number of 5 powers of 5 contributes a 5. No, sorry, no higher powers. Now we need not to calculate all the higher powers, isn't it? That means there is no need to calculate which one. Uh, no need to calculate the powers. That means the number of powers of 5 which are less than or equal to 112 and divisible by 5 cube 125, but it is not possible since 112 is less than 5 cube 5